Hi everyone, in this video we're going to go through the solutions for this homework that I gave you, which was actually part of the 2023 SAC. So you can see section 2 and then it's split up into different parts. So we're going to have a look at the solutions. So the solution's already been done, but I will mark important parts and discuss it as we go through. Okay, so we've got given D, so D is some domain, is a real value, mapped to a real value. H of x is equal to the square root of x squared plus b, where h of x is equal to this composite function, okay, f of g of x. So if we've got a composite function, we can determine what f of x and g of x are. All right, so we've got f of x and g of x. So here's our function here. So we can say, all right, that function is made up of two other functions or composed of two other functions. So what I've got on the left side in blue is one solution, and then on the right side in green is another possible solution. Okay, so we could have had square root of x, so f of x could be the square root of x, and g of x is x squared plus b. So when you do f of g of x, you get h. All right, so that's what it meant. You're just basically separating h of x, which is a composite function, into its two separate functions. Or you could have separated it like this. So the square root of x plus b and g of x is x squared. So I've basically, in my solutions, in blue follows these two functions and in green follows the other. So two possible answers, you really only had to do one, not both of them. Okay, so let's scroll down. In part 2, state the domain and range of f of x and g of x. Now, sometimes you might see things a little bit distorted, so you can see that's a little bit distorted there. It's just sometimes when you scroll, the writing comes along with it. So apologies in advance. All right, so just identifying the domain and the range. So because our function has b in it, just you did have to have your domain and range in terms of b. So if you did your functions in blue, like the blue ones, then that's your domain and range. And if you did it in green, there's your domain and range. Okay, not overly difficult. You could use your calculator to help you, but just remembering that you can't take the square root of a negative value. So x does have to be greater than or equal to 0, which you can see here. And your range also has to be greater than or equal to 0. So you could also graph that function if you wanted to. As for x squared plus b, it's a parabola. So the domain for a parabola is any real value, and the range, so basically that b is shifting it up or down. So from b to infinity, and it is a positive parabola, so b is your lower limit. And you can do the same thing for the green. Okay, I'm not going to go through that. Question 3, explain why b has to be greater than or equal to 0 for h of x to be defined. All right, so again, two possible solutions, one in blue and one in green. So for f of g of x to be defined, the range of g of x must be a subset of the domain of f of x. So if you're ever dealing with a composite function and it refers to it being defined, basically you give this statement. So your range of your inside function, so in this case g of x, must be a subset of the domain of your outside function, which is f of x. So in blue, I've just done a number line. And you can see there. So the domain of f of x is 0 or greater, and your range is also, so if we just go back up, because your range is in terms of b, we do need b to be greater than or equal to 0, and we can see the same if we were doing green. All right, and then there's just a little statement underneath. Oops, what was part 4? Can't remember the question. Let's just go back up. Come All right, find D, the domain of h of x. Okay, so your domain of g of x is equal to the domain of f of g of x. So your domain of h of x is equal to R. So this statement here we did when we were doing composite functions. So your domain of your inside function is going to be the domain of your composite function. So your domain of g of x, so if we just go back to up here, you can see they're both R for g of x. So yeah, g of x is R, g of x is R for the domain. All right. Now, just in terms of marking scheme, you can see there's marks allocated to the section, but not to specific questions. So it's not like 1 mark each, you get an overall mark. So, and that's just mapped to your outcomes. So your outcomes for your SACs. So your first outcome is basically your skills. The second outcome is your application of those skills. And your third outcome is use of technology. So they've already been mapped. So basically you just answer the question. Oh, sorry. I am home. Dog barking. All right. Don't know what she's barking at though. Part 2b. All right, so let b equal an integer. So an integer is just a whole number between 0 and 5. So in your SAC, it is often open-ended. So you need to, so in order for it to be open-ended, you might have to make choices. So you can let b equal 1, 2, 3, 4. Probably also 0 or 5. Wouldn't make any difference, I don't think. All right, so consider the inverse of h of x. So we're looking at the inverse of h of x. So h of x is the function above. Okay, so the square root of x squared plus b. So you're just letting b equal something. All right, so explain why the inverse of h of x isn't defined. So basically it's not defined because h of x is not a one-to-one function. So remember, to take the inverse of a function, it needs to be one-to-one. So even though you haven't chosen a value of b, if we just sketch it, so let me just sketch, all right. See if I can do it without opening my laptop. So y is equal to the square root of x squared plus and some value of b. So if we did 2, there it is. You could also on your calculator and on Desmos, but you won't be using Desmos, you could add a slider. So if you wanted to put b in, you can add a slider on your calculator. So you can see basically going anywhere from 0 to 5. Whoops. All right, so you can go below 0. So you can see what happens. All right, so it's not a one-to-one function. So you need to restrict your domain to be able to take the inverse of a function. All right, so let's go back. Okay, so part 2, restrict, well, that's what it's telling you to do. Restrict the domain of h of x so that your inverse is defined. Write the rule for h of x with your chosen value of b. So for the inverse to exist, the domain of h of x must be either. So we're either taking the positive or we're taking the negative part of it. So if I just go back to the graph, okay, I might just make it, let's make it b equals 2. Okay, so you're either taking, and I can't draw on this, I don't think, yeah. You're either, actually I can draw over it, you're either taking this part, all right, so that section or this section, all right, so just restricting your domain to make it one-to-one. All right, and writing the rule. Okay, so you restrict your domain, so it can either be 0 to infinity or negative infinity to 0, so either is fine, and then putting in your value of b. So I did say it had to be between 0 and 5. So not 0 because then, yeah, and I don't know why I restricted it to 5. Maybe, I can't remember. Anyway, so just choosing a value of B. Now, in your SAC, let's say you came across this question and you were like, what does she mean? Okay, you can ask a question like that. What do you mean choose a value for B? Now, to me it seems quite self-explanatory, but sometimes we overthink things and you're like, oh, what's B? All right, and I'll just tell you. Choose a value, 1, 2, 3, or 4. Okay, easy. And then you can move on. All right. Let's just go back up. Part 3, find the inverse. Okay, so you can see I've just highlighted different values of B. So that's just changes depending on your value of B. So finding the inverse, we do switch X and Y, and then just showing the working out for that. So you've got your inverse here. All right, and just making sure you have your domain as well. All right, moving along, part 4. Sketch the graph of both h of x so that the inverse of h, not the the inverse with restricted domain, and sketch both the graph of both. I think that should be and. Sorry. And annotate key features of the relationship between the function and its inverse. I feel like that's sketch the graph of both h of x and the inverse of h and annotate. Okay, yeah, so I don't know why the words say that. So, all right, so there's the graph of f of x and its inverse. So you would have to be sketching this by hand. So key features you would need to have are your x-intercepts and your this asymptote, which is the line y equals x. Oh, it's not really an asymptote. In this one it is, but let's not call it an asymptote. It's just the line y equals x. So you didn't necessarily have to put that in, but it does show that it does not cross. Okay, so those graphs won't cross across that line, and there's no intersection points for this graph. All right, but you can have it, so that's why I don't want you to assume that that line y equals x is an asymptote. All right, what have I written under here? Why have I written stuff? Key features. All right, explain key features. All right, so key features. F of x has been reflected along the line y equals x to produce the inverse. The y-intercept of f of x is 0 square root of b, so whatever chosen value of b you did. Because the x-coordinate and y-coordinate switch for the inverse, the x-coordinate is that. So, yeah, that's probably enough of an annotation. So you could either do it straight onto your graph or writing it there. All right, so just when it says to annotate things, you need to just look at features and an understanding that you know what is happening in your graph. All right, part 2C, discuss why the domain and range need to be considered for composite functions and inverse functions. So composite functions and inverse functions will definitely be on your exam. And I just think a strong understanding of composite functions and inverse functions is vital, having to understand so many other aspects of functions. So so I might just read what I've written because I might be repeating myself because I haven't read it since last year. So for a composite function, so f of g of x, the function is only defined when the range of g of x is a subset of the domain of f of x. Okay, so it's talking about why you need to consider the domain and range. So that statement, you know, can come straight from your notes. You can have your notes in this SAC, in your SAC. This is because what we put into a function, the x value must have a possible output, so a y value for the substituted function. So you, so you need to have, if you put something in, something else needs to come out. All right, so for inverse functions to exist, the original function must be 1 to 1. This is because the x and y coordinates switch position and there can only be one possible x value for each y value. So if it's not 1 to 1 and you're switching, so if you've got, say, 2x values for one y value, how do you switch them? So yeah, it's got to be a 1 to 1 function. Otherwise, it isn't possible to swap 2 or more x values for one y value, which is exactly what I just said. Okay, and dunsies. So you can see in the SAC, you're not just writing about, or you're not just doing problems, mathematical problems, you're showing a deeper understanding of, in this case, composite functions and inverse functions. So, you know, things should be in your bound reference just for you to refer to. And you can see how, like, you just get to the point, right? We don't need to waffle on and write a whole essay on it. Just get to the point. You can use graphs to help you. You can use a number line like I did here. Anything you need to do to kind of explain what you mean. There were 2 other sections in this, I think just 2, in this SAC. So I might just quickly show you so you can get a feel for them, and I'll give them to you at another time. Oh, actually, let me just pause. All right, so I actually just condensed that one so we didn't have to keep scrolling. So you can see in part 1, we're dealing with a cubic. All right, so just an understanding of how to get those values in a cubic. All right, so if you're being given some points, how to get the cubic. Graphing, annotating things. So you can see there, we've got a cubic and its derivative. So understanding the relationship between a function and its gradient function. So the derivative, it's also its gradient function, where it's positive, where it's negative, and so forth. So really loved this to get a deeper understanding. So I will give you this before your next SAC, before your first SAC. I don't know why I didn't fill that in. Maybe I did that over the page. So looking at what the values of A and D have on your graph, blah, 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 making comments on different values of B. So you could use a slider to do that. Then you can see, actually, I think that's all my explanation. So I had graphs there. I said to students, you know, graphing things is really good. So it's visual, blah, blah, blah. All right, let's move on. Yeah, so just different parts. A cubic, explore what happens to the graph of g of x for different values of p, q, and r. So, you know, what's happening if p, q, and r are different? What if p and q are the same? What if p, q, and r are all the same? So different things like that. What if they're 0? So just having an explanation there. Number 2 we just did, so let's scroll. Part 3. So looking at, so you're going to be given probably functions like this where you need to know the family of those functions. So basically that means you're not given a exact function, but what happens if values change within that function. So understanding what, you know, restrictions need to be placed on it for it to exist, the domain and range, stuff like that. You can see graphs being used, and this is a long SAC, so if you're looking at this and like, oh my gosh, so much information, yeah, you've got a lot of time to do it, so really just taking your time, and time to think as well. So it's important in SACs that you're given time to think. Anyway, I don't expect you to write that all down. I just wanted to show you what else was coming because I'll give you the whole SAC anyway. All right, guys, ciao.